Kent Beck. Thank you so much. Is my voice booming too? Oh, good. It's an unenviable position to be between the audience and their beer. But here I am, and I get you for an hour. Who's calling time for me? Hi. Thank you. I'm going to start with a story. I'm a storyteller, so I'll start with a story. It was kind of late-ish, maybe. So I don't have the exact date, but I was in my office. I was living in Southern Oregon at that time. It was nighttime. I remember it was dark outside. And David Saff, this is about 2005, 6, something like that. David Saff and I were working on JUnit. JUnit was originally written on an airplane going from Vienna to Washington, D.C. Long story. It was a big surprise how popular JUnit was. But it became surprisingly popular. The more popular it got, the more people added value to it. The more people added value to it, the more popular it got. And eventually it becomes a platform. And then there's even more ways for people to add value to it. As is the way with anything that grows incrementally, the tree requires pruning from time to time. And there was one function that actually you have a test case and you want to run it. And that function had gotten bigger and bigger and more complicated over time. And it had gotten to the place where we couldn't change anything about it without breaking something else. And open source software is an interesting economic proposition because you have a very small budget for development. You have very demanding users. And especially at that point, JUnit was a very fundamental piece of infrastructure. It was, if you wanted to build the entire world of Java software, JUnit was one of the first things that you had to build because everything else had JUnit tests. So we took backwards compatibility very seriously. We took regression testing very seriously because if we didn't, trying to fix those problems would be way more effort than we had time available to devote to it. At the same time, we knew that we wanted to continue evolving it. And this function, run test, I think it was called, had just gotten so big and complicated that it had become what was Adam's phrase? It's this the intersection of complexity and frequency of change. So over the development rhythm for JUnit is once a week. David Saff and I would get together. David's at Google now. At the Boston office, we'd get together remotely and we'd pair programming. So all development on JUnit happened via pair programming, remotely if necessary, because we couldn't always be on airplanes. And so we had recognized that this function was our bottleneck, and we started doing our version of Adam's splinter. What was it? The splinter pattern. So we started teasing this bowl of spaghetti apart into individual strands of spaghetti. And what resulted from that, extracting one function after another, was a long chain of function calls. So instead of being one big function, it was a function that would do a little bit of work and then call another function. That would do a little bit of work, that would call another function, all the way down. And one of the varsity level, the graduate level refactorings in object-oriented programming is taking a function and creating an object out of it. And done at the right time in the right place, that can be absolutely magic. So over the course of this 2-hour programming session, David and I took the functions in this long chain, which was itself hard to understand, and we created objects for each one of those. And as we were doing it, it was dead easy because we'd set up the little functions in this long chain were all quite simple and quite separated. So creating an object for it, and the next one, and the next one, and the next one. So that was step one, and kind of that happened quickly. And then we looked at this and we said, well, instead of just calling into this object, we'll call that object, we'll call that object, we're going to create a collection of these objects and invoke them externally one at a time. And then we thought, well, what do we call these objects that we've just created? Well, there was an object that would set stuff up before the test ran, and then there was another one that would tear stuff down after the test ran. And we thought, these are kind of the rules of the game of running a test. And this 2-hour session, which was easy and magical at the same time, was the origin of JUnit's rule feature. Because once we'd created these objects, we said, well, these are just the ones that we want. Other people could want other rules. How are we going to let them say, I want my rule to execute as well? Well, let's just add an annotation for that. And it was kind of an afterthought. We hadn't set out at the beginning of those 2 hours to create the rule annotation. It was something that emerged out of a bunch of little tiny, individually easy changes. And those little tiny individual changes emerged out of probably 6 weeks worth of careful preparation for that. Taking this big bowl of spaghetti and pulling it apart. How many people have used rules in JUnit tests or something? Yeah, it's not like a major feature, but when you need it, it's really cool. Because you can create context for your tests. That context is easily reused in other tests without having to confuse that with inheritance between test classes. And it works out really nicely. So the lesson for me there was that making big changes doesn't have to be the result of making big changes. It can emerge just from little locally optimizing changes that you make, just really for reasons of aesthetics. So, my name is Kent Beck. I am a recovering Facebook employee. It's been 2 weeks since my last employment at Facebook. Do you recognize this introduction? You're supposed to say hi, Kent, now, but you don't. Thank you very much. This has been an interesting transition. It's still, my good hoodies are still Facebook hoodies. So I clearly haven't separated yet. I was at Facebook for 7 years. And I learned lots and lots of interesting lessons there. Many of the lessons that I learned at Facebook was that I didn't know near as much as I thought I knew. Facebook has a very particular way of doing things that's quite different than anything that I'd written down in one of my books. And so I had to kind of swallow my pride when I went there to learn how things were done differently in the Facebook style. So this is my first public talk since I left Facebook, and actually I gave a workshop yesterday, and I kept saying we and us in speaking with Facebook. It's going to take me a while to get rid of that, but there you have it. I wanted to try something fairly ambitious. I spent most of my time at Facebook focused on engineering education. So teaching engineers how to be better engineers. And I wasn't working, I didn't write lots of code. I didn't think lots of thoughts about, I don't know, design patterns or something. I was thinking about engineering culture. So I decided to give myself a fairly ambitious abstract for this talk, to talk about the uses of symmetry in coding. And I worked on the talk in little bits and pieces over the last couple of weeks especially. And this morning, as I was just preparing to put the final finishing touches on the talk, the entire thing fell apart. So that was interesting to realize that the topic I'd chosen I couldn't speak to at all, and so it's kind of good news, bad news. The bad news is for me, I didn't understand this topic of symmetry nearly as well as I thought I did, and the bad news for you is you don't get to hear about it. But the good news is I get to turn around my topic. And here I am, the anchor leg of your day of thinking about development. I get to summarize what I've heard from all of the other excellent speakers. And the even better news for me is they don't get to respond. So here's what I heard. All of the talks, in one way or another, were about making sense of programming and programs. So, we weren't given lots of details besides this beautiful title, Beauty in Code. We weren't given a lot of direction about what to talk about, at least I wasn't. So it's always interesting to step back in a situation like that and see what emerges. And sometimes there's no particular common thread. In this case, this theme of making sense came out of what everyone did. So James talked about making sense of the emergent properties of programs. Looking carefully at the actual behavior of programs and seeing how that compared to the specification. Now, I want to issue an apology publicly for dissing what he does well. I'll say in my defense that was, thank you, James. That was the 18 years earlier narcissistic bastard me. And so I can believe that I said that, but it's got to be hard to be really good at something that you know is important and have somebody piss on it. So my apologies. One of the challenges that we have is we use this word test, and we each mean something, and we each mean something valuable, but we don't mean the same thing about it. So this idea, one of the things I had to learn at Facebook is pass-fail is while it's important, it isn't the most important thing. I remember the first code that I ever pushed at Facebook, nervously watching, am I going to crash the system? I'd written all my tests and, because I'm me. And I did crash the system. But anyway, So I see that came a little later in the story. So I see the production code successfully pushed to 6,500 of 6,600 servers. And I freaked out. What's on the other 100 servers? Yeah, who knows? Like, really? Nobody knows? Like, my code is mostly running, but sometimes not running? Yeah, it's fine. It doesn't break anything. Like, really? So having code that will run under those conditions, it's really hard to unit test that. And that was one of the lessons. Feedback loops are really important. Tests are a feedback loop, but they're not necessarily, in the world of trade-offs, the most important ones to include. And the kind of feedback loops that James was talking about have to go through production before you can see how do all these pieces come together and how do they all behave. Aslam took that a step further to talk about making sense of the development of a software system where the existence of the system changes its own requirements. You may or may not have heard my rants about this word requirement for things that aren't required, because you don't necessarily have to do them all and people are still happy. So why do we call them requirements? That's why stories came out. And then people polluted it by calling it user stories, but that's another long story. Aslam wanted to make sense of what we're doing, not just in terms of the thing we're doing, but the effect that it has on the world. I think I get asked lots of questions about the Agile Manifesto, and I'm not just a signatory of the Agile Manifesto. I am the first signatory of the Agile Manifesto alphabetically. And Mike Beadle is still pissed off about this, but BEC, ha ha ha. So something we missed, I think, in there, like I get lots of questions, and I don't answer lots of questions, and don't come ask me questions, because like I was really sick at the meeting. I was taking some industrial grade antibiotics, and I can't remember shit about what happened there. So, plus, like that's way old news. There's new stuff. You want to ask me about my new stuff, I'll talk your ear off, but in any case, there's a line in there that the best measure of a system is running code. And I think that's the issue that Aslam was addressing. That's a remarkably narrow-minded statement. The measure of a system is the effects it has on the world, intended and unintended, measurable and unmeasurable. If you want to understand your system, you have to go much beyond inputs and outputs and look at, are we number one yet? And if we're not, what do we need to do to get to number 3 and then to 2 and then to crush those guys? Adam's presentation was again about making sense. We build programs and they have a complexity all their own, especially if multiple people work on them, or even if one person works on them for any length of time, complexity emerges that nobody really intended, which is why we need the kinds of tools that Adam's talking about to make sense of this thing that we've created. This is an active area of experimentation of mine. I enjoyed having a giant code base and a whole bunch of very active developers at Facebook. I could go and mine the repositories there. Now I have to go find other repos and figure them out. And I'm looking forward to trying out the tool to see what it brings. I think there's a ton of understanding of the social nature of code as well as the actual structure of code to be had looking at that kind of data. But again, Adam's trying to make sense of, hey, we all got together, we made this thing, it behaves in bizarre ways, as James would notice. It has bizarre effects and unexpected effects on the world, as Aslan would notice. And Adam builds these tools that lets us say, what the hell's going on? Facebook's quite a cussy place, so I will probably use language that's not safe for children. I'm in Sweden, dude. Does that make it okay or not okay? Okay. Sue. Fuck yeah. All right. Kevlin's talk was again about sense making. In this case, sense making about what it is that we do. These ideas that we have as somebody who tries to come up with. Now I'm gonna backtrack on what I was about to say. I was about to say, as somebody who tries to come up with new things, I don't try to come up with new things. I try to make sense of the world. Oftentimes the things that I'm told I ought to be doing don't make any sense to me. So I just do what makes sense to me. As a weird person, that's interpreted as innovation. Sometimes it's interpreted as courage. Like, how could you say that we don't need big specs? You know, this is back in the extreme programming days. How could you say that we don't? That's how I can say it. It didn't seem like a matter of courage for me to express this, just more like, well, this doesn't make any sense to me. Kevlin was pointing out that the problems are eternal and recurring. And we've been trying to address these problems for as long as there have been programmers. One of the magic things about the history of programming is just to get into programming early on, you had to be wicked, wicked smart. So the early pioneers were just really smart and really thoughtful about what they did, because if they weren't, they couldn't do it at all. So if you go back and you read the historical documents, there's oftentimes interesting bits and pieces that you miss. I've had the wonderful good fortune of interacting with many computing pioneers. And when I talk to somebody who was in at the beginning of something, they always have a take on it that's surprising and unusual. I was telling Kristen Nygaard stories last night at the gin bar, and just remembering talking to him about object orientation. He would say things, and I'm like an object guy. He would say things that still surprise me because he understood it at a level that nobody else understood it, having been there at the beginnings. The world takes on the part of the understanding that it's ready to take on, but something's lost in the process. And every once in a while, so I'll use a vinyl reference since, you kids are into vinyl these days. Every once in a while, we should take the 45 that has the big hit and flip it over and play the B-side and go, well, what's on the back of that? There is something else there. There are insights there. The problems we face are not unique and brand new, which is how I made my living at Facebook. I'd have some poor young engineer come to me and say, I'm so uniquely broken. I'm the worst programmer here, and everybody's going to find out. And as soon as they find out, I'm going to be fired. And I'd say, imposter syndrome. They're like, there's a name for this? Oh, yeah. Let me tell you about last week. And then I tell them some story, and then I give them some exercises to do, go have this conversation with that person, and then write this down, and then come talk to me. And honest, that's what kept me going at Facebook. The look on some little engineer, engineer-lit, what's the term for like a little proto-engineer? There's got to be, okay, we'll come up with this one eventually. The look on their face when they realized, yeah, I'm weird. yeah, you're weird, but you're not alone. You're not the first person to face it. That's just a wonderful feeling for me as a teacher. These problems that we're addressing, concurrency, been there for a long time. Yes, we kind of got off into the weeds. We don't have to stay there. It's a choice. There are alternatives. There are alternatives from the past. There's alternatives that make sense today. Maybe you'll come up with something brand new. Who knows? Do something that makes sense to you. That was the message I got from Kevlin, that we look at all of these big problems that we have, and it's easy to be overwhelmed and think, oh, what can we do? Well, you know what? These problems have been around since the beginnings of programming, and some of the problems that we deal with go back to Roman engineers. Probably went, I don't know how to lay the stones to build this bridge, and somebody's going to figure out that I don't know anything about stones, and then they're going to chop my head off. And some older Roman engineer probably went, imposter syndrome, and go write this thing and talk to the guy, and then you'll be fine. So there's this sense that yeah, it looks like we're in this crazy, chaotic world, but it's really not that bad. Yes, we have problems to solve. No, it's not going to be easy, but we are part of a history and a sweep, and we all have our parts to play, but it's not like we invented these horrible problems and there's just no way out. Lewis's presentation was interesting to me. I had to make a decision very early on in extreme programming. Were we going to go the certification route or not? And I can get kind of nasty about this, so I'm going to try and rein it in. My decision was that there would be no extreme programming certification. Actually, that's a lie. There is an extreme programming certification, and here's how it goes. You come and you work for me for free for 6 months, and you pay me $150,000, and I will write 10 pages about your strengths and weaknesses and post it publicly. That's the XP certification. And nobody's taken me up on this yet, but there it is. Because those 10 pages would mean something, right? There's backing, there's skin in the game, the incentives are pretty well aligned. And I think of certification as an attempt to make sense of what we do as engineers. Like, what's the repeatable process for teaching an engineer? Well, if you looked at the process I went through to learn how to be an engineer, you would not want to repeat that. Guaranteed. And I think that's true of most people. Like, I don't think we even have a grasp of what the fundamental skills are. I mean, I have my list, but they're the things that I'm proud of and the things that I enjoy doing, and that list is very different than other people's lists. So, do I get to impose my list of basic skills on you? Do you get to impose your basic list of skills on me? My understanding of the problem grew more complicated and nuanced based on my experiences at Facebook. So when I got there was very little unit testing, no pair programming, no particular planning cycle, and yet they were kicking ass. This 700 million people a month were using the service. We were continuing to add features. See, I just slip into it. They were continuing to add features. It was continuing to grow and scale. Like, they were doing everything wrong and getting things mostly right. So it took me 5 years to make sense of what was going on at Facebook. Turns out different parts of Facebook operate very differently in a very different structure. And how many of you have heard about 3X, Explore, Expand, Extract? Okay, so I can look at that as an opportunity for the rest of you to to try and get the point across. And I can go on about this for hours, but I'll give you the 2-minute version. How much time do I have? Half an hour. Excellent. I'll give you the 3-minute version. So here's how it goes. You have the early days of some project. Say you want to write a new testing framework. Who in the world would want to do that? But anyway, you want to write a new testing framework. You don't have anything to lose. So the value maximizing behavior in the early phases of a project is to try experiments and discard them if they don't work. Your biggest risk in the early days of a project is indifference. Nobody cares about this project. Oh, another testing framework. And yet, the one thing you know for sure is 10 years from now, 20 years from now, somebody's going to come up with the next testing framework or the next programming language or the next instruction set architecture. All these things that seem like they're absolutely rock solid today, they all started as just somebody trying some stuff out. If you want to maximize the value you create, you say, okay, I have this much money or I have this much time, I'm going to run as many experiments as possible. Because I don't know what's going to be that one program, like JUnit was for us. We flew from Vienna to Washington, D.C., and then on to Atlanta, where the UPSLA conference was. We handed JUnit to Martin Fowler, who said, this is great. Martin tends to be an encouraging person, so I discount that. The next day, though, we had 30 people clamoring to get floppy disks. You know, floppy disk, the little 3D printed save icon. All these people just like, oh, can I get a copy of this? And this had never happened to us before. So if you're in this exploratory phase, your best bet is to minimize latency. Well, would people care about this? What's the shortest path to handing it to somebody to see if they care about it? If I spent 10 times as long making something carefully polished with beautiful documentation, and then I handed it to someone and they went, nah, no, I'm not interested. You could say, well, I could have just given you a crappy product and you would have given me the same feedback. So next time, I'm going to treat this as an experiment, not as a long-term bet, but just an experiment. So there are places in Facebook that work in this exploratory style, and it's when the lifetime of the code is short, the consequences of failure are either small or you can limit them, and you don't know how people are going to respond to it. So sometimes I call this it's like a game. It's like you've got a football, the real football, not the American one. And you figure out, okay, here's how we play football. Fine, good. Now, one of those ideas takes off. Poof. Now you're scaling rapidly. The servers are catching fire. You're running out of disk space, and you're running out of power, and you're running out of floor space. Each one of these problems that you run into, you couldn't have anticipated before you scaled, because this has just never happened to you before. And number two, you don't have time to do more than just kind of duct tape the whole thing together to keep it up, to get you to the next crisis. So I call this the expand phase. In expand phase, one of these experiments has taken off unexpectedly, and now you're scaling faster than you believe you can. Customers are screaming at you. We want this and it doesn't work, damn you. That's wonderful progress, because just before you tried that experiment, nobody cared about your thing at all. Now they're screaming at you. Ha, thank you. The rules of that game, that expansion game, are completely different than the rules of the exploration game. Exploration game, crazy creativity. if you have a bad idea and you can make it cheap enough to try it, you should just try it. Like this is how TDD came about. I had built the first testing framework in the XUnit family for Smalltalk. And I remembered a book that I'd read as a kid. So my dad was an engineer too. And he would bring books home and I would read these books like cover to cover, absolutely obsessed with what was in them, not understanding a single word. And then I'd go back and I'd read the whole thing again. So like the Burroughs 6700 instruction set manual is all in here someplace, even though I didn't understand it at all. It's a pretty cool architecture, just in case you're looking for some light reading. So one of these books said, here's how you write a program. You take the input tape, tapes, right? It's like a long, thin floppy disk. Never mind, anyway. You take the input tape and you look at the contents and you type in the output tape that you expect. Because how data processing happened was this tape to tape. You'd have a tape, a program that would transform it. Now you have another tape and you mount that as the input to the next process and so on and so forth. So you type in the output tape that you expect manually. And then programming is the process of writing this program until the actual output tape matches the expected output tape. So that was floating around in my brain for 20 however many years. And I had this testing framework and the two ideas collide because most valuable ideas is 2 or 3 ideas coming together because there isn't anything new under the sun. So those ideas came together and I laughed out loud. I thought, well, if I took this type the output tape thing first, if I took that schema seriously, then what I would do is I would write the test before I had the code. That's so stupid because you know it's going to fail, right? You want the test to pass. And that's why you write the test after you write the code, because you're such a genius that you're going to write the test and it's going to pass and it's going to be proof positive of the utter immensity of your skills. Except, of course, then the tests fail, and then you go through, and I have a whole talk about that genius shithead roller coaster that people go through, but that's maybe for another day. Okay, so I had this crazy idea, and I thought, yeah, but how hard would it be to try? Like, this is clearly a stupid idea. How hard would it be to try? And I thought, well, I can just do stack. And half an hour later, I was hooked. The anxieties that I felt while programming, that just kept getting worse as I became more experienced, those anxieties just dropped away. I'd say, well, I'm not done until all the tests that I can imagine are all passing. But I don't have to make them all pass at once. I can just type one in and then make that one work and type the next one in and make that work. And eventually I go, can I think of any other tests? No, I must be done. And I was just completely relaxed. I thought, what a remarkable transformation. But that came out of a process of literally trying stupid ideas. That's just a habit of mine. You know, somebody says, obviously X. I always think, well, what if not X? How hard would that be to test? And usually, I mean, the consequences of this is you spend a lot of your time doing stupid stuff. But then every once in a while, one of these takes off. And it's wonderful because you have no competition because nobody else is dumb enough to try the ideas. There's my recipe for innovation. Okay, so that's the explore phase. You're trying out crazy stuff as quickly as you can. And you're exploring a space, literally, a space of possible problems to address and possible ways to address them. And you don't know where that magic's going to happen. You're going to find that people really do care about this. So to efficiently explore the space, you should have a lot of diversity. Now, when things start going crazy and you're having this vertical growth and you're constrained by some rate limiting resource, the game is completely different. That's all about focus and getting everybody into one room. That phase doesn't last long, which is good because it's not sustainable. That's the one where you pull long hours. and everybody's in there, and they're things are happening nobody's ever understood before. But I remembered I was talking about certification. I can come back. Which of those do you teach? Right? Like, which of those is engineering behavior? Not even done yet, because once vertical growth has started to tail off and the limits to scaling are, the ultimate limits to scaling are clearer, then you can start doing something that looks like adult engineering. You can start making estimates. Before that, you can't make estimates. You can just react. Once you have 100 people on the team and you have millions of users, you can start plotting the graph and looking out 5 years, and it all makes sense. But that's a completely different game again, that extract game where you're extracting value to feed back into the next set of explorations. That extract game is a completely different game than this reactive expansion game, which is completely different than this wildly creative exploration game. So if you're going to certify, which set of skills do you certify? Now, XP days, I tried to write the one set of rules that would match all 3 phases because I didn't even know there were 3 phases. And so things like estimates versus no estimates, right? That depends on the phase. If you're exploring and you've never done this before, don't estimate, like time box. Or just have attention deficit disorder. So you're experimenting with this until you're experimenting with that until you're experimenting with that. It's a pretty good way to do resource allocation when you're exploring. But it's a stupid way to do resource allocation when you have 100 people working on the same system that's bringing in billions of dollars. So if we were going to have certifications, which set of these skills would we certify? Can we be wise enough to certify 3 different sets of skills? But then there are other environments that don't fit this model at all, like life critical systems, where there's still risk management, there's still a sequence, but all the trade-offs are completely different. So that's one of my troubles with certification. Yes, we seem to magically make enormous value in the world, and no, we don't know how that works. I have trouble with the certification as a way of understanding that because, well, first, there's a huge incentive problem. The incentives of the people being certified are not aligned with the incentives of the bodies doing the certification, are not aligned with the incentives of the people purchasing the services of the people who are certified. All those incentives are going in completely different directions, and so we see the kind of situation that we have today, where you'll simultaneously hear widespread contempt for certifications, and you'll see more and more people getting more and more certifications, putting their money exactly in contradiction to the sense that what we're doing doesn't make any, doesn't go together, that the incentives of the players are dramatically misaligned. So I applaud the intention to understand what we do and how it creates value, and I think it's just way premature to try and boil that down into the book of knowledge that will fit each and every situation and that we can use to throw at people who violate the precepts of that book of knowledge. Ina's talk, and I wanted to call out one thing that she did that I really appreciated, which is before she talked, she specified what she was going to speak about. Now, I understand there are differences of opinion about this, whether you should say what you're going to do before you do it, or you just do things and then see what comes out of it. I do like this, let's call it test first style, where you say what you're going to do in advance of doing it. I think there's some advantages to that. Aino's perspective is one of taking the sense that we have made of the world and spreading it to other people. And something else I really liked about her presentation was the humanity of it. We're all people. We have these brains. We're all, we're not in the environment that these brains were tuned to operate well in. Predators are not trying to kill us on a daily basis. Although I did hear a story last night in the gin bar about some wolf biting somebody on the butt. So perhaps there are, yes, Martin, that's my call out to you. Perhaps there are cases where there are predators that we have to worry about, but yeah, that's not a daily problem. Here we are, we have the brains we have in this environment that they're not really built for, and we have to adapt to that. And the point that Aino made is that understanding the other person's perspective is the best thing that we can do if we want to share the sense that we do make about the world. So that was the theme for me of the day, is trying to make sense of the world and understand, not just do the next thing, but to take that step back and say, hey, what is it that we just did? What can we learn from that to inform what it is that we do next? I did want to address this question of beauty, because that was the thing that really grabbed me about the title of the conference. I'm a big fan of beauty in code. I think that there's code that evokes a sense of beauty in me when I read it. There's certainly code that evokes a sense of revulsion in me when I read it. Sometimes that's my own code, so there you go. But there's a point there about engineering that I wanted to make sure that I highlighted. First, there's a contradiction built into applying the standards of beauty to code. There's two forms of beauty that we can talk about. We could talk about the beauty of the system as it exists. So you check out, as I did, I checked out the latest version of what was I looking at? Gradle, something like that. And you can look at it as a snapshot. Here's this thing, and there's these functions that call those functions, and they're composed in a way that's easy to understand, and the complexity is parceled out, and the names are chosen just so it's easy to understand both the large-scale flow and then dive into the details if you want. That evokes a sense of beauty in me when I look at it. But there's another sense of beauty, which is the beauty of changes. That moment when you say, you won't believe this. We had this crazy idea. All I had to do to implement that crazy idea was I overrode this and I changed this one if statement there, and it just works. Those deltas that just magically do something, those feel wonderful. Those evoke in me also a sense of beauty. This system is beautiful not because of it in its moment right now, but it's beautiful because it enabled me to realize my dreams in a very efficient way. And those two experiences of beauty are directly contradictory. If I spend all of my time making beautiful changes, I'm going to end up with ugly code. And if I try to maintain beautiful code and never back off, that's not the layers. The layers are like this. We can't violate that. Then I'm going to lose many of my experiences of the beauty of changes. And the reason I think this is important for engineers is my experience of it is that beauty is processed in a different part of my brain than other things. So my symbolic thinking feels to me in a part of my brain, that was activated when I was in high school and my angry algebra teacher gave me 40 trig identities because I'd been a jackass in class. And I started working through these trig identities, and about halfway through, I was, mad. And about halfway through, I got it. And I went, oh, if I can just transform this problem into that problem, and I already know how to solve that. Ooh, give me another one. Ooh, I don't see how to do. Oh, I can break this into these two parts and transform this one into that. Da, da, da. I had this aesthetic sense. That part of my brain, there's a symbolic part of it, which is just pure symbol manipulation. But there's another part of it, which is this enjoyment of the beauty of code. And I think that I, as an engineer, do my best work when both of those senses are invoked. It's hard for us, and this is not empirically proven. I would love to see much more study about this. But if I want to do my best work as a programmer, I want the symbolic part of my brain working. I want my sense of beauty and wonder working. I want to be emotionally activated. I want to care about what I'm doing because I know I'm a better engineer when I care about what I'm doing. Oftentimes I listen to music because the patterns that go on there, I think, stimulate my thinking in ways that it isn't already stimulated. So you could say beauty is this abstract concept, and wouldn't it be nice if we could work on beautiful code? And I think there's a lot more to it than that. And so when I got the invitation to come talk at Beauty and Code, I thought, well, this is great. I'll be around a bunch of people who are also talking about beauty and code, and it turned out that none of the other speakers addressed beauty directly. But I think that it's a topic that I have way more questions than answers to, but my nose just tells me understanding what makes for that experience of beauty in either looking at a snapshot of a system or looking at the change necessary to get a system to add some behavior. I think that's going to make for better engineering over time. I want to close with something that's very practical. I had an experience about 6 months ago. I was getting tired of all this people-y stuff that I'd been doing at Facebook, and I just sat down with some ugly code and cleaned it up. For about a week and a half, it was, so I found this function, that function, and it was about 500 lines long, and they're nested ifs, and I love Adam's indentation, the indentation metric. That is a beautiful metric. So it would have failed. You would have had buffer overruns if you had tried to calculate it on this function because it was just so ugly. And so I just started making little tiny changes. If the value of variable was computed here and it wasn't used until down here, I moved the computation, if I could, based on data flow, I'd just move the computation down next to where the variable was used. That kind of thing. I changed names. I recognized another refactoring, put things that seemed to change together. And so I made this series of diffs of a single file, and they all seem to be very trivial. And at some point, I started to get the picture, oh, this is what this would look like if it was beautiful. I hadn't seen that when I started. I just had this one function, which was horrible. I could zoom out and say, oh, if this file was beautiful, here's what it would look like. Oh, okay. And I remember the second to the last diff, we had code reviews, of course, which is a horrible idea for different reasons. But again, I'll get, yeah, I just have to drop stuff like that because I'm independent now, and I need to leave some breadcrumbs. So this series of code reviews, and the initial set of comments from reviewers were, oh, thank God somebody's just cleaning some stuff up because things just seem to get worse and worse. And the second to the last diff, somebody actually made an honest comment on the code review. They said, you don't seem to be changing anything. I said, just wait. And the final diff took, we had stuff that was in this file. There was stuff that was similar and stuff that was different. So I'm pulling the stuff that's different away from the stuff that's similar so that the stuff that's similar becomes identical, and then the identical stuff can get unified. And the last diff was taking the entry points for this file and moving them all up together. And now it read like a little essay. It said, well, here's the entry points. This is like the table of contents. Here's what you're going to see in the rest of this file. But at no time did I make any big changes. Oh, and so that code reviewer on the final diff, his comment was, oh. I thought, yes, I win. So I wrote this up as the life-changing magic of tidying up code. And I realized, oh, I'm actually good at this. That I have a process that I go through in order to do this kind of tidying up. And the rules are pretty simple. If it's hard, don't do it. So if I'm ever like, I think I can move this to here, but I'm not sure, then I just don't do it. I'm only going to do obvious stuff. Another rule is put the intermediate stages into production immediately. So as soon as I move that variable calculation down 3 lines, I'm just going to put that into production. Because I don't want weighing on me, maybe I broke something. I'll find out for sure. Another one is only do this kind of work when you're fresh, when you're rested. This isn't something to do when you're tired and a little woozy. This is like, okay, I have half an hour before lunch. I'm feeling like doing something, but not something big. I'm just going to move some variable declarations around. Okay, so you do that. Another rule is that I practice. If I can see I want to get from here to here, but I don't see how to do it in small steps, I'll try it this way and then throw it away. And then I'll try it that way and then throw it away. So a lot of the work that I do when I'm tidying up just gets turned into lessons. I was going to say throw it away. You don't throw it away. You learn the lessons and you move on. And this is something that I'd encourage you all to go and try. If it seems like a big deal, you're doing it wrong. It's a bunch of little deals that adds up to big deals. And it doesn't need to be, I'm going to go spend 2 months cleaning up. This happens in 15-minute, half an hour chunks with frequent feedback and lots of rest. And then you can go and add features to your code in between. But making a habit of just tidying up will enable you to experience that sense that beauty is something that you have influence over. You have some crappy code, okay, happens. I mean, inevitably happens, but you don't have to just live with it. You can pull yourself out of that. You can give yourself the experience of beauty a few minutes at a time every day if you so choose. And if you do, I believe that your experience of engineering will be transformed. My time's up. Thank you all very much for your time and attention today. And thank you to the organizers of the conference for putting together an absolutely fantastic day.